Welcome to Get Your FRQ On. This question is from 2019. It's question 2, and it is calculator active. In the question stem, we have a particle P moving along the x-axis, given by a differentiable function v of p. V of p is measured in meters per hour, and so forth. And there is a table for values of t as well as values of v sub p of t in meters per hour. We're also given that the particle P is at position 0 when time is equal to 0. In part A of this question, we are asked to justify why there must be at least one value of t between 0.3 and 2.8 at which v sub p prime of t is equal to 0. So in the question stem, we're given that v sub p of t is differentiable. This allows us to conclude that v sub p of t is also continuous. So if we use the formula for the average rate of change over the interval from 0.3 to 2.8, we get v sub p of 2.8 minus v sub p of 0.3 over 2.8 minus 0.3. And since v sub p of 2.8 and v sub p of 0.3 are both 55, this is going to come out to 0. Therefore, we can conclude that there must be at least one value of t such that t is between 0.3 and 2.8 and v sub p prime of t is equal to 0. In part B of this question, we are asked to use a trapezoidal sum to approximate the value of the definite integral from 0 to 2.8 of v sub p of t dt. So the actual question on the test states which intervals to use for your trapezoidal sum, but given the values in the table and the interval we're integrating over, the only ones that would make sense are the ones provided. That's 0 to 0.3, 0.3 to 1.7, and 1.7 to 2.8 specifically. But again, given the bounds of the integral, those would be the only ones that make sense. All right, so setting this up, we have the integral from 0 to 2.8 of v sub p of t dt, which is going to be 0.3 times v sub p of 0 plus v sub p of 0.3 all over 2 plus 1.4 of v sub p of 0.3 plus v sub p of 1.7 all over 2 plus 1.1 times v sub p of 1.7 plus v sub p of 2.8 all over 2. And then inserting the values directly from the table, the integral from 0 to 2.8 of v sub p of t dt equals 0.3 of 0 plus 55 over 2 plus 1.4 times 55 minus 29 over 2 plus 1.1 times negative 29 plus 55 all over 2. And when we simplify this, we get the integral from 0 to 2.8 of v sub p of t dt is 40.75. Don't forget this is a calculator active question, so you don't have to do these calculations mentally or even in scratch paper. You can just type it into your calculator and have your calculator come up with that answer. In part C of this question, we have a second particle Q, and we are asked to determine when the velocity of particle Q is going to be greater than or equal to 60 meters per hour, and to calculate the distance traveled by particle Q on this interval. So in the actual question, we are given in the statement of this part that the velocity of particle Q at time t is given by the function 45 times the square root of t times the cosine of 0.063 t squared. And since this is a calculator active question, we're going to use our calculator to solve it. The velocity of particle Q will equal 60 at t equals 1.866181 or t equals 3.519174. And to help us with a calculation after this part of the question, we're going to call that first value m and the second value n. In addition, the velocity of particle q will be greater than or equal to 60 on that interval from m to n, and the distance traveled by q on that interval will be the integral from m to n of the absolute value of v of q, or v sub q of t dt, and that turns out to be 106.109. And so particle q traveled 106.109 meters over that interval from m to n. In part D of this question, at t equals 0, particle q is at position x equals negative 90. Using our answers from part B and the function for v sub q, approximate the distance between particles p and q at time t equals 2.8. From part B, we know that the position of particle p at 2.8 is the integral from 0 to 2.8 of v sub p of t dt, and that turned out to be 40.75. And we can use the formula for v sub q of t in part C to calculate the position of particle q at 2.8. That's going to be negative 90, plus the integral from 0 to 2.8 of v sub q of t dt. And because this is a calculator active question, we're going to solve this using our calculator. Turns out to be 45.937653. To calculate the distance between the two particles, we simply need to subtract 45.937653 minus 40.75 is 5.188. So from this, we conclude that at t equals 2.8, the two particles are 5.188 meters apart. If you appreciate my AP Calculus AB free response question solutions, make sure you like the videos and subscribe to my channel. Don't forget, you can also follow me on X at x.com/getyourfrqon.